All right, lights, camera, action. All right, so today is Friday. Thank God it's Friday. March the 12th. I mean, it's just, March is just zooming by. It's awesome. Getting close to summer, which I call teacher heaven. And so, the big perks. We don't make the big money, but we get the summer off. And so, it kind of balances out. All right, so what we're talking about right now is the strengths of acids and bases. So if I'm looking here, based on the composition and on the conjugate acid-base pairs, so compare HNO3 to HNO2. Which one's the stronger acid? HNO3 is the strong acid, this is the weak acid, right? So what does that make this conjugate compared to this conjugate? Both, first off, they're both conjugate what? Bases. Acids make a conjugate base because once it donates the hydrogen, it has the ability to accept one back. So if this is a strong acid, what does that mean about the strength of the conjugate base? It's weak. So this would be a stronger conjugate base. Because it's a weak acid, it doesn't want to ionize fully, which means that once it loses the hydrogen, it has a much stronger attraction to get it back. Because it didn't really want to lose it much in the first place. Okay? So then, H3PO4 versus H3ASO4. Which one's stronger? Why? There's still the oxygen to hydrogen ratio is the same. Phosphorus is going to be more electronegative than arsenic. Now, are you going to have to memorize that? No. What's the trend in electronegativity as you go down in a family? Decreases as you go down, increases left to right. Okay? So we just need to know that trend. So fluorine is the greatest, francium is the lowest electronegativities. Okay? So we can just see phosphorus and arsenic are in the same family. Therefore, arsenic's below it, so it has less electronegative. It is less electronegative. So it's going to, this is the weaker acid, H3ASO4. So what does that mean? What does that make these conjugate what? Bases. Which one's the stronger one then? ASO4, right? It's going to be the stronger conjugate. And then lastly, you have HCO3 versus CO3 minus. Okay? So this came from H2CO3, this came from HCO3. So which one's a stronger acid? H2. So this one is going to be the weaker conjugate base. That's going to be the stronger conjugate base. Because it didn't even want to lose one hydrogen, let alone two. So this is going to have a strong attraction to get hydrogens back. Okay? So we should be able to use the same concepts with acids and bases as far as for the conjugate side. Strong acids make weak conjugate bases. All right? Now, number 91. Just talk about, for each statement that's false, correct the statement to make it true. Is so, in general, the acidity of binary acids increases from left to right in a given row on the periodic table. Is that going to be true? Binary acid is going to just be HX, right? X being the nonmetal. What's going to determine the strength of that acid? Size. The size, right? Bigger or smaller is a stronger acid.
No, bigger.
Remember, a strong acid means a weaker bond equals stronger acid. Because what makes an acid, the hydrogen has to be ionizable. So the weaker this bond is between the H and the X, the stronger the binary acid is going to be. So what happens to the size of the nonmetal as you move left to right? It gets smaller. So it should be right to left. It's actually going to get weaker as you move left to right because the atoms are getting smaller, so this bond is getting stronger. Okay? Binary acids are, again, the hydrogen's on the nonmetal here, so it's all about the nonmetal. On the oxyacid, the hydrogen's always on the oxygen, so it's much more about the OH. Okay? So in general, the acidity of binary acids decreases from left to right in a given row. In a series of acids that have the same central atom, acid strength increases with the number of hydrogen atoms bonded to the central atom. Okay? They have the same central atom. So this is really going to be talking about oxyacids. Okay? Is it going to be the number of hydrogens bonded to the central atom? If it's... Oh, the bells are off? Okay. Let's just finish this one though, and then I'll give you all a break. Just keep it going. Okay? Let's assume this is an oxyacid. This is a little ambiguous. In a series of oxyacids that have the same central atom, acid strength increases with the number of hydrogen atoms bonded to the central atom. No. Okay, it's going to be the fewer hydrogen atoms bonded to the oxygens. Okay, so this one's just kind of all screwed. But this is the one I really wanted to say. H2TE is stronger acid than H2S because TE is more electronegative than S. Is TE going to be more electronegative than S? Okay, again, we don't memorize it. We just look in the periodic table. We see TE is below S on the periodic table in the family, so it's less electronegative. So what does that mean? Why is H2TE a stronger acid, though, than H2S?
The size.
Okay, let's use like a sentence.
The tellurium atom is much larger than the sulfur atom, so the bonds are weaker.
So the bond between the hydrogen and the tellurium is going to be weaker than the bond between the hydrogen and the sulfur. Binary acid's all about the size of the nonmetal. Okay? I'm looking at you.
Oh, I thought if it was bigger, that would make the bond stronger.
No.
Okay.
Okay? They're farther away from each other, so the longer the bond, the weaker the bond.
Okay. Alright. Checks out.
All right, so we'll take a short break, refresh yourself. We'll stop and just have a short video and then a long video.